We use electricity every day, but seldom think of what it really is that works all these appliances. Unfortunately, we can't see electricity as we can see water from a tap. But since water is also a source of energy, there must be water pressure. To obtain this pressure, water is stored in reservoirs, from which it is led by pipes to the power station below. You can see that height affects water pressure and alters the power of the jet. In electrical terms, you can think of pressure as the voltage, which you'll find printed on the data plate of most appliances. You'll find wattage mentioned too. To explain this, let's make the jet do some work, because wattage indicates how much work an appliance can do. Increasing the pressure makes the wheel turn faster. But voltage, or pressure, is not the only factor involved. Rate of flow is important too. Obviously, the glass fills more quickly from a high-pressure jet than from a low one. There's a greater flow. The bigger a pipe is, the more water can flow through it, and this is true of electrical conductors as well. Think of electrical flow as current, which is measured in amperes. Power cables are thick and can carry large currents or high amperages, while thin wires can only take small currents of only a few amperes, as you'll see on a card of fuse wire. But the work done by a water wheel depends on pressure and flow. The power of an electric motor depends on voltage and current, and power is measured in watts. There's a direct mathematical connection between volts, amperes, and watts. Knowing the wattage of an electrical appliance is useful not only to calculate the work it will do, but also how much electricity it will use. Your meter registers that in kilowatt hours, referred to as units. Kilo means 1,000, and so you can use 1,000 watts for 1 hour before 1 unit of electricity is recorded. You'll pay less than a penny for this, which is not a lot when you think of all the work electricity does about the house.